AI has the potential to transform the world, and DOE is at the forefront of that effort. Our national labs have the fastest supercomputers in the world, as well as its leading scientists and engineers. We're now at work at developing the next generation exascale machines. When those capabilities are applied to AI technologies, there's no limit to what we can do. We're doing an enormous amount of work already, yet we're just beginning to see the possibilities of AI. So let's join together. Through the power of AI, let's change the world, let's impact people's lives, and let's strengthen and reinvigorate our nation.
One of the biggest benefits to the work that we're doing is to provide energy and electricity to the grid. The type of research that we do, as you can imagine, requires a lot of data. And one of the best ways to understand large amounts of data is using what people call artificial intelligence or machine learning.
The domains in which you apply artificial intelligence works quite well in fraud detection and spam detection, and the way that cyber attacks might be manipulating the power grid seems to be one of those areas where artificial intelligence is particularly applicable.
We're using it in cancer research, trying to build AI models that can predict the response of tumors to drugs. And so this idea of using AI to analyze the molecular properties of a tumor, we can then predict which drugs would be most effective on which tumor.
Please welcome back to the stage the U.S. Department of Energy's Chief Commercialization Officer, Connor Prohaska.
Good afternoon. Well, come on up, sir. Yes, sir. Here we are. Well, I hope everyone has had a great afternoon of our breakout sessions, and we're really excited to come back together here and really have a really exciting discussion with two individuals that don't need much of an introduction, but I will real quick. Dan Briette, who is our Deputy Secretary for the Department of Energy, and Michael Kratsios, the Chief Technology Officer for the United States. Michael, I've already given you an introduction. You said it was too generous, so you don't get any more. Deputy Secretary Briette, I do want to highlight for the part and the people that may not know your vast experience, most recently as a Senior VP at USAA, VP at Ford Motor Company. Before that, you have been a Chief of Staff for the House Energy and Commerce Committee, Understanding the Hill. This is your second tour at the Department of Energy. Previous administration, he was Assistant Secretary for Congressional Affairs and Intergovernmental Affairs. He's been a state regulator and an Army vet. So there's a lot going on there that really lends some great experience to this discussion and what we're going to talk about. But I'll start with you, Michael. We talk a lot about the effort that you put forward in leading the AI initiative at the White House. Mm-hmm. For those of us, or for individuals here that aren't in government, what does that really mean? What does an executive order on AI, what is the practical implications of that?
Yeah, absolutely. I mean, when we came to the administration, we realized we had to take sort of significant action on ensuring American leadership in this very important domain. There's a lot that the federal government can do, and I think, over the course of the past decades, many of you have probably seen wonderful reports that administrations put out that talk about the importance of particular issues or places where we can do better. So when we started the process back in March, we had a really clear goal in mind. We wanted the strategy that we were going to release to be as actionable as possible. So when we created this, we wanted there to be specific things that individual agencies could do and that the White House could do, which, could be measurable, and when we got them out the door, we would actually making a difference in driving and maintaining and ensuring this leadership. So for us, this was over a year-long process of bringing together stakeholders at a summit at the White House in March of last year called, we named it AI for American Industry, and that was an opportunity to kind of hear from the community on what you would want to see in a national strategy around AI, and through a very robust and grueling interagency process, we're able to generate an executive order. And in some ways, I don't think we can understate how much of a big deal this is. This really is the strongest and most powerful tool that the president has in his policy arsenal to deliver on, to name a priority, and then essentially direct agencies to execute it. So we launched the American AI Initiative, which is our national strategy, via executive order on February 11th of this year. And going back to that actionable thing, we really had three main pillars, in which in each of those we wanted to create actionable things we could do. So under the first pillar, there was a focus on research and development, this idea that the U.S. must lead on R&D. And what the important role that the White House can play in leading that R&D effort is to bring the agencies together under some sort of coordinated mechanism. And we created what's called a Select Committee on Artificial Intelligence. This is one committee that has members from multiple agencies, including the Department of Energy, from DARPA, from IARPA, from NIH and National Science Foundation. And this is a group that actually coordinates the efforts of our R&D efforts across the agencies. The other thing we did is the president actually gave a directive to the agencies to prioritize AI R&D in their budgets. And it also called for the Office of Management and Budget to produce a budget supplement for the first time in history, which would lay out how much money we're actually spending on AI. So these are actual deliverables that we're moving on. The second pillar is about workforce, and that is how we can ensure that we have a strong and sustained pipeline of AI talent that will make the next great AI discoveries. And again, we thought, what are the tools the federal government has at its disposal in order to drive that goal? And what we settled on was, look, we put out lots and lots of money every year to graduate students around the country to pursue various degrees in scientific fields, and the president directed agencies to prioritize AI as an area for grants and fellowships. And we're seeing that actually trickle through the community over the course of this year and should be ramping up. And the third pillar is around removing barriers to AI innovation. This idea that we need to have a regulatory structure which actually encourages innovators in the AI space and creates an environment where people are excited and are able to commercialize their AI products. And the greatest thing that we can do is actually work with the National Institutes for Standards and Technology, which is a part of NIST, to promulgate standards around the development of artificial intelligence. And that was something that was done by NIST already. And the second piece of it is really this focus on sort of the creating a safe, trustworthy, robust, and ethical artificial intelligence. And how can we as an administration guide that and drive that? We've done lots of efforts, and most importantly, international domain, to sign on to a set of international AI principles which affirm this. And then these principles are going to be used by the agencies as they develop AI regs.
So, following on that same thread there, the mandate comes, an executive order from the White House. Sir, Dan, how do we react at the Department of Energy, and how does leadership react?
So we immediately follow the guidance. That's the first thing we do.
Good answer.
We all do work for the President of the United States. So the Secretary of Energy, Rick Perry, decided immediately that we needed to coordinate our efforts within the department itself. For those of you who are not familiar with the Department of Energy, I hope this experience with our XLab has given you some exposure to that. But we have 17 national laboratories, and we have many, many program offices within the department itself. And as we surveyed that landscape and went across, it was very apparent to us that almost all of them were doing something with regard to AI. But it was little pieces here and little pieces there. So what the Secretary did was to create an office within the department itself to coordinate all of these activities and to have us focus on the things that really matter. And we have, in a very short period of time, identified a number of different things where we can have a meaningful, measurable impact in the short run. One of the things that he is personally passionate about, given his experience as an Air Force officer, was the amount of data that's available in places like the Veterans Administration, which is literally just a couple blocks away from the U.S. Department of Energy. Every veteran, everybody who's been in the military, has given up their DNA, has given up their health records, has been provided treatments, if you will, within the service in which you served. All of that data resides at the VA. They have the data. Guess what we have? We have supercomputing power all throughout the department. And Secretary just, through intuition said, well, wait a minute, how about if we marry the two? How about if we get together? It's a great idea. We're going to pursue that with vigor and passion, but there are other ideas and other things that we can do as well. And the creation of this office allows us to coordinate those activities within the department. So I think very consistent with the President's executive order, very consistent, frankly, with just common sense.
Absolutely. And I want to put a real fine point in this so you don't have to read between the lines. If you're in there in industry and you are not engaging with our computing power at the Department of Energy, you are missing out on a great tool that could be maximizing your efforts and the taxpayer dollars. So that's a little bit of a break, but I want to make sure that is not lost here. Engage. So down that same train of thought, so we look across the department, we've got a ton of stuff we could possibly be doing. One of the big things that the Department of Energy does is national security, roughly half of our job, right? So where do you see not only artificial intelligence helping our national security mission, but then artificial intelligence kind of more broadly playing into the national security discussion?
Sure. Well, the application of AI to things like encryption or other areas in which we're very concerned about, cybersecurity in particular, I think it's probably the most important area in which we're going to focus on in the next few months at DOE. Grid resiliency, the idea that our grid can be penetrated by other partners, many of whom are adversaries to us, and turn out the lights literally in places around the world that we don't want them turned off. We have to close those loopholes, and we're not going to do it with human technology or human interaction, if you will. Machine-to-machine learning is very, very important. The application of artificial intelligence in this area is just absolutely critical. It's a gaping hole, in my opinion, right now with regard to cybersecurity. So I'm very anxious to get moving. I know that we have several labs who are working. I ran into Steve Ashby and P&L right over here, and I know Argonne's doing great work. All of our laboratories are doing great work in this area. We want to focus those efforts and push them forward even further. It's very, very important that we do that. Also with regard to the weapons programs, as we think about what the future weapons programs look like, importantly what other countries are developing, the application of artificial intelligence to those types of programs is absolutely critical as well.
Michael, obviously we're not the only people that care about national security in the federal government. A lot of departments do it. What can you do at the White House to help, I guess, knock down the walls?
Absolutely. One lens we sort of think about this issue through is how does the U.S. and sort of our like-minded Democratic-led partners around the world, how are we developing artificial intelligence versus the way some of our adversaries, other people around the world are? It's something that we take very seriously, and we think that we talk a lot about American leadership in AI, and that's something that I drive every day and that the White House is deeply concerned about and that our great agencies are pushing. But the real fundamental question is why? Why do we need the U.S. to show this leadership position in artificial intelligence? And I think one of the best answers to that is because of the fundamental values that underpin its development around the world. So we have adversaries and other people around the world who are using artificial intelligence in ways that are completely foreign to us, in ways that really do not align with anything that we believe as Americans. There are countries that are using it to surveil their people, to imprison minorities, to infringe on other people's basic human rights. And these are not the ways that we believe that technology should be developed. This is technology that can help benefit and uplift people all around the globe. And we want to make sure that as this technology develops and gets further commercialized, it is developed and underpinned by those American values. So the question is, how can we make sure that happens? And I think option one that sort of I talked about a little bit earlier is we need to come together with other like-minded democracies around the world and commit wholeheartedly to developing artificial intelligence with these values underpinning it, whether it's robustness, fairness, accountability, trustworthiness. And that's something that we did as America in an environment where the United States is rightfully very skeptical about a lot of multilateral agreements. We made a very big move by signing on to the OECD AI principle. There's a set of principles that America and the 36 other OECD members came together and agreed to in Paris. And I think this shows that we as Western democracies want to come together and provide an alternative to the way that other countries around the world are developing this technology. And if we can continue to make sure that it's developed in this way, we can ensure that it's developed in a way that sort of protects our national interests for many years to come.
So building on that, Connor, just a little bit, that's very consistent with the other activities that we have within the Department of Energy. We're obviously responsible for stockpile stewardship. We are responsible for the nation's nuclear warhead system. We're also responsible for many of the technologies and some of the newer technologies that are coming to the civilian side. So we understand very clearly that this technology has a dual use capability. AI probably has dual use capabilities as well. But very consistent with this approach, we have signed on to international treaties. And importantly, we demand, if you're going to use US technology in the nuclear space, you agree to what's called the Section 123 of the Atomic Energy Act, which means that you're not going to use this technology for the development of a nuclear warhead. And I think those types of treaties, getting those types of values imposed in this system or infused with this newer technology is very, very important to us as a government, and it's why we must lead. We must lead this effort.
Absolutely. So we've kind of done it before in some areas.
Yeah.
Artificial intelligence is going to be a different one. Switching gears a little bit off national security, something we just finished a parallel track on mobility. And I think the first time, Michael, you and I talked, we talked about the automation of transportation, and you've worked a lot about that at OSTP. Sir, professionally, a former car guy. And
Still a car guy.
Still a car guy.
Still a car
Just
guy.
not professionally.
Right.
I'd love to hear your thoughts. Dan?
Well, I think, look, everybody's excited about autonomous vehicles and what that means. I think that is still going to develop over the course of the next few years as to whether or not we can develop cars that are completely safe and, available to the broader section of American public. One of the beautiful things about the auto industry is that, they design cars at every level. If you want a high-end car, you can do that. If you want a low-end car, you can do that. As we move to autonomous vehicles, I hope that we consider those types of considerations as well, that we don't have autonomous vehicles be out of the reach of ordinary Americans. I think that's very, very important. But I think there's other areas too within the automobile space that AI is going to play a very important role. We think about efficiency quite a bit. We think about the efficiency of the combustion engine as well. It's still here. It is likely to be here for quite some time. We're excited about EVs. We're excited about the technologies that are coming online there, but we're also excited about what AI can do for the current automobile and what we can do for the current engine. And yesterday, I was over at Fermilab and at Argonne, and I was looking at some of the work that they're doing, and it's absolutely fascinating. And I think if we are aggressive in applying this technology to the automotive industry, we can make some very, very short-term gains. Very important for us to do.
Mm-hmm.
Michael, how are your efforts going at OSTP with that?
Yeah, I think when we sort of launched our larger initiative right after inauguration, our big focus was on ensuring American leadership in emerging technologies. And one of the first things we wanted to do was find sort of a tangible example that most Americans could connect with on potentially how the regulatory system in Washington had stifled innovation. And to us, the one that came to mind and one we presented to the president actually in the East Room at an event in the summer of 2017 was this issue of drones or unmanned aerial systems, or UAS. So this technology has been around for some time now. We know that drones can fly. But if you ask any technologist in Silicon Valley, it's something that they think they have a handle on. You even had sort of Jeff Bezos and Amazon do that very famous Amazon commercial many years ago, where they showed this hypothetical delivery of your package. But the reality is, commercial drone operations today are still extraordinarily restricted. You can't fly drones for commercial purposes at night over people or beyond visual line of sight. Our greatest technology companies are actually testing their operations abroad. Google has a test facility in Australia. Amazon is testing in the UK. There's rumors many American technology companies are based in northern Washington, so they can literally drive over the border and test over there and then come back at night. So this was a really tangible example of administration where it was like everything the president was talking about, where we have a regulatory system which is actually holding back innovation. We have the greatest technologists, the greatest technology companies, the greatest country here, but yet we're sort of exporting this innovation abroad. So we wanted to highlight that. And we addressed it at that event in the summer, and we wanted to kind of tackle it. And a great example of how we're trying to is this concept of regulatory sandboxing, this idea of using small pockets around the U.S. where we can sort of push aside the rules for a second and see what would happen if we allowed some of this technology to take hold. And the president directed through executive order in October of 2017, Secretary Chow at the Department of Transportation to establish a drone pilot program. And the concept here that the White House pushed was this idea that we should allow state, local, and tribal communities to apply to the FAA in partnership with the private sector to test operations which are currently illegal. So you could imagine we had Choctaw Nation, for example, which is part of this test, and they were able to apply to the FAA and say, look, we want to test this innovative idea, on our land, will you give us approval? And we've had 9 tests running all over the country for the past year plus, and it's really provided an incredible amount of data and feedback to the FAA as they're trying to develop their regulations to allow commercial ops to happen. So whether you're in Choctaw Nation or you're up in Anchorage or in San Diego or in North Carolina, all over the country these tests are happening. And we had a big breakthrough just 2 days ago where we had the FAA issue its first sort of commercial operating license to a drone airline. So UPS now has the first drone airline in the United States, and that's kind of its first big step towards commercial drone ops. So for us, we continue to think that the future of transportation is one we take very seriously, and we consider in some ways the federal government can often be an important bottleneck because we want to make sure the security precautions are considered, but we really need to move the ball forward, and we're doing a lot on AVs and drones, and a pet project for me that I focus a lot on is this idea of supersonic flight. With the Concorde out of commission, we currently aren't flying supersonic. We should be able to fly to the UK in 3 hours, but we aren't, and that continues to be a regulatory hurdle that we're trying to work forward.
Mm-hmm. So we've talked about mobility. We've talked about healthcare. Should we talk about energy?
Maybe.
So Dan, how do you see our artificial intelligence office integrating into our applied energy offices, the energy world in general? Grids. You talked about efficiency a little bit.
Yeah, sure. I mean, I think one of the short-term gains that we can make is to look at efficiency. So if you think about your financial portfolio, all of us probably have some sort of financial planning in place. One of the things you learn very early in that process is to diversify your portfolio and reduce your risk. Same thing applies to the generation of electricity. If you can optimize your portfolio and optimize your diversity, perhaps you can reduce emissions even further than you think you can today. It's fairly easy to point out that a windmill has less emissions than a natural gas facility, or a solar panel has less emissions than a coal plant. That's very easy to understand. But if you're a utility today and you already have sunk costs in many of these generation facilities, you want to know how to optimize what you currently have to reduce your emissions. And AI is an important component to that. So we're working closely with the utility industry, CEO level on down, CIO level, CTO level, depending on the company. And we're working very closely with them to share some of the things that we have already learned within DOE and importantly within our labs, so that they can optimize that mix, that generation mix. We think it's a good thing. We've reduced emissions, carbon-related emissions here in the United States over the course of the last decade and a half by 14%. That's due to a number of different factors, not just AI, but that's considering while this economy has grown by 17% in the same time frame. So we're already seeing success, not entirely due to AI, but if we apply this type of technology to what we currently have existing in the energy infrastructure, those numbers increase dramatically.
It's a force multiplier.
And I think the private sector is making big steps in this too. One example that we've seen, which has been very interesting, is a project that Google has worked on with DeepMind. So as you know, probably Google runs massive data centers all around the country that use a lot of energy to function. And one of the big projects that DeepMind undertook was, how can you use artificial intelligence to optimize the power consumption of these data centers? And they've actually made really big strides to be able to reduce the energy usage. So innovation is happening in the private sector as well, and it's something that we should try to share with sort of as many industry partners as possible to make a difference.
So we're going to wrap up a little bit here, but I'm going to pose a question for each of you individually, not the agencies you represent or the offices you represent. Michael, most exciting and most impactful for artificial intelligence?
To me, I think this answer probably won't be too surprising. I think healthcare is a domain which continues to impress me in the areas and opportunities available for AI making a difference. And as someone who is sort of watching multiple agencies make incredible strides in AI, this is one area where we see huge and important collaboration. And I think as Deputy Secretary mentioned a little bit earlier, this idea of the VA partnering with the national labs to to sort of help our veterans is a huge first step. The big strides that NIH is making in therapeutic discovery and drug discovery, I think this is a huge resource and an incredible potential for us as a country. And as the Secretary mentioned, I think a little bit earlier, the size and scale of the cost of the American economy of healthcare is dramatic. And if we can use artificial intelligence to help optimize that spend, it can not only improve the lives of millions of Americans, but I think it also can be very beneficial for the larger economy.
Dan?
Yeah, Connor, I think I'd have to agree with that. I mean, as a veteran, as somebody who's passionate about taking care of those people who have served our country, I think this is probably the most exciting area for me personally in AI, as it is for the Secretary as well. We can really make good headway here with treatment, everything from PTSD to simple concussions. The Secretary has been very active with this. He just met with some folks out in California to talk about what we might do next. We think, we looked at some of the initial applications and some of the initial technology that's been developed using AI. He mentioned one this morning in the conversation where, an app on your phone with a drop of blood can tell you whether or not you've been concussed in about 3 to 10 minutes, give or take. So that simple diagnosis can determine which hospital you should go to immediately. And it can be life-saving in many cases. If you go to the wrong hospital and they can't diagnose a simple concussion, you could be in peril for quite some time. So if you think about the application of that on the battlefield, the application of that in everyday life, with our kids, the application of that for the NFL. It's amazing technology, and if we can help solve some of these things today, we have the obligation to do so. A little bit less exciting, but just as important to me personally as the Chief Operating Officer of the Department of Energy, the application of AI to our own internal operations at the DOE could be very important as well. And as I've told the Secretary, and as he's reminded me that I told him on several occasions, if we're going to help develop this, if we're going to help promote this, if we're going to help fund this, then we ought to be willing to use the tools that we develop internally to the DOE. And that's very important, and I would hope that working with our White House partners, perhaps this can be an effort that is spread across the entire federal government.
Absolutely, and we're going to talk a little bit about a tool that we've developed at OTT.
Perfect.
Is doing just that, incorporating artificial intelligence. Well, that's a great place to end this, and I want to just thank both of you, sir, for your leadership at the agency, the leadership at the White House. Without these two gentlemen, this event doesn't take place. Without the resources and support that they provide, this initiative does not take hold, and I think we deserve to give them all a great round of applause. So thank you very much.
Thank you, Connor. Thank you.
Thank you, sir.
Please welcome Rob Bechtel.
You still up here with me? You can stay, because I like the whole Abbott and Costello routine.
There you go.
We'll decide who's who.
I'm going to do a little intro.
He's going to do an intro, but I want to say something. We're about to use a PowerPoint to discuss AI on a leading edge website. So do the math on that one.
Well, we'll start with what's really exciting, as we mentioned there at the end of the discussion, one of the places that we are already starting to utilize artificial intelligence is in our lab partnership service. Lab partnership service, if you remember, I talked a little bit about the 3 ways and business lines that we have in the Office of Technology Transitions and how we work to accomplish our mission, and that's policy, access, and promotion. Access is exactly what the Lab Partnership Service is designed to do. I'm going to turn it over here to Rob Bechtel to talk a little bit about what Lab Partnership Service is. It's labpartnering.org, but we want to encourage you to go use it, break it, find out better ways that we can use it and utilize it to marry you up to the technologies, the people, and the facilities that exist at the Department of Energy. This is a great tool, and I'll turn it over now to Rob to tell a little bit about it. So,
Sure.
With a PowerPoint.
So you with a PowerPoint with a clicker that should work. Cool. So that's the website, and it is a government website, so we'll call that what it is, but it's very useful. Department of Energy has been doing technology transfer websites for the whole 10 years I've been at DOE. We've had many iterations. This is the latest one, and by far the best and most powerful we've ever done. Typically, we've always led with a thing, the innovation, the patent. And if you ask me, a patent couldn't be more boring. I know a few people out there are patent attorneys. They like them. I'm sorry. But for us, we do try to do other things. The lab partnering service gives you the ability to discover what DOE does across all of its national labs, plants, and facilities that I have access to. And then it allows you to give you an opportunity to connect. The whole purpose of this website was to ask the question, the worker, what do you do? Not what do you want, not who are you, but what do you do? And how can I help you do what you do and do it well, quickly, in a time that has meaning to you? So this is a lab partnering website. You can do a keyword search if you happen to know the magic word, or we can find a way to have you find it through different forms of entry into the site. I have 20 labs or plants on the website, 180 experts. It changes every day. It's actually 177 today. 207 facilities online. That's way beyond the standard user facility list. Why? Because DOE has a lot of places for you to engage. You can gain entry into the National Lab infrastructure to use these facilities. You typically do not rent the whole building. You rent a part of the building. When you're in that building, you're not necessarily the expert using the machinery. You've designed the experiment. The experts come from the labs. So you are, in essence, renting a team, a tool inside of a facility. We have 1,219 technology summaries online. Those are technologies that the national labs have provided to us for purposes of saying, these are ready. These are technologies we think are ready to go to market, and here's how you can connect with us to use them and pull them out quickly. The last thing, of course, is patents. Well, we have about 37,977 patents online over the last 20 years. That's an awful lot of work. Okay, so we want to talk a little bit about artificial intelligence. This website, we built it based on the learning experiences of prior years. And one of the goals we had was to improve how we did what we do. So we used a little bit of our artificial intelligence, machine learning over the course of the last 3.5 months to look at how we tie innovations to each individual lab using USPTO data, and to also look at how we categorize each and every one of those patents that come into the system. And what we had learned in prior years was that we were essentially averaging about 40%, 45%, 48% in terms of matching, which was useful, but ultimately not what I wanted to see. So what we then decided to do was a machine learning or a test model, and we came up with an improvement, certainly on assigning patents to their labs, going from 45% to 98% matching. And that was done in a 3.5-month test. In terms of categorizing our patents, which we do, and I'll show you at the very end here in 3 minutes and 42 seconds, is the idea that you can go ahead and see how I get to a patent that's on engineering, chemical engineering, and all the way down that tree. Our problem was similar to that. We had a low percentage of matching within that, and it would kick out to an other category. So we tried to improve that. Again, you see a basic improvement of up to 62 or 82%. Okay, Lab Partnering Service has essentially 4 key areas. There's a search for experts, which in some sense is a dating website. If I could make my own mobile app dating website, I'd call it Smasher. So expert search connects you with any of our leading experts from across the national lab, across a selection of technologies. It is not all of everything that DOE does. That's far too vast. We do select about 20 technologies, and we do change them. Every year, the project of the Lab Partnering Service works to do a user-centered design effort. Our project for this year has been running for 3 months, at the end of which we will have finished talking to about 30 different internal and external customers about what they like or don't like, what technologies are coming, which ones are leaving. And we alter the site. We're very key on getting rid of old stuff and putting new stuff on there. You can also do the facility search, a technology summary search, and the visual patent search. This is what the expert search looks like on a large screen. And the whole goal, as I said, was to find that person, find his relevance to the work that you're looking for, and ultimately to be able to click Ask Me. You can ask him a question. Your question will go directly to that expert and the partnerships office. So we chaperone every date that we try to put in play. And so the ultimate goal here is to make it possible for you to do your job, to connect and potentially get your question answered in a quick turnaround. This is all the labs. So every lab is on the website. We showcase those resources that are on the website. It is not everything they all do. But you're able to click on any one of these and immediately go to that lab's technologies or their patents or experts. These are the facilities, technology summaries. So there's 1,189 of those online. The goal here is, again, to make it possible for you to read those technology summaries and ultimately, in each one of those, connect with the lab. Here's your facilities, 196 facilities, same thing. High-level descriptions of each facility will take you off to each facility's website, enabling you to connect directly with that facility manager or their partnerships office at that lab. This is a visual patent search, the thing we did our AI work behind it. This thing's been around for about 9 years, and the goal here is to make it possible for you to find where DOE does its work. It's a topographical map of areas of domain, scientific domain, that DOE does its work in. It only works on 20 years worth of patents. You can do a longitudinal search within it. This is designed from point and click. You can click through the device all the way down and ultimately pull out a list of patents that you can export and use those to turn around and talk to a lab about these innovations that I want to get to. This project is maybe one of the most useful in understanding what DOE does. If you're interested, I recommend that you go and click into Biology Life and go all the way down and find the patents on the salmon cannon, because we do work in ichthyology. So in some sense, when we describe it as the Department of Everything, it's there. This is the project we have on display. We have the lab partnering service on display. I ask that you come by and talk to us. We'll give you a full-on demo of it, and then hopefully we'll get some ideas from you on how to make it better.
Thank you. Thank you, Rob. And I want to encourage everybody during our networking and social times and when you're not in here, if you haven't already, go visit the booths. See, we have 16 of the 17 national labs represented here. We also have exciting, right out of the gates, the first display of our artificial intelligence technology office that you've heard us speak a lot about. Their setup in there. Please go talk to them, engage with them, and go and play around with the touch screen and learn a little bit more about LPS and the efforts we're doing there. Thank you all so much.
Please welcome back to the stage Rick Stevens.
Okay, we're almost done today. There's one more thing between now and drinks. First of all, if you haven't noticed, inside your badge, there are these two tags. They say, drink ticket. Two of them. The reception has been generously sponsored by Intel. And before you're allowed to go back there and cash in these tickets, though, we've asked Wei Li from Intel. Wei Li is the Vice President General Manager of Machine Learning Performance. It's going to be his job and his team's job at Intel to make the new Intel machines, and particularly Aurora, be an excellent and performant platform for machine learning. And so we're very glad to have him here. He's going to give us a few words before we go cash our drink tickets in. I thought I'd say a little bit about Wei Li. So he's been at Intel over 20 years. He's led many innovative software efforts related to AI, clouds, data centers. He's kind of seen it all, been there. Mobile devices, and involved in hardware and software co-design. So he's seen all the computer science and computer architecture related work at Intel. Most recently, he led the team that won the Stanford Dawn Bench. So Dawn Bench is one of the leading efforts to benchmark artificial intelligence methods, particularly deep learning methods, using a technique that actually tries to estimate real-world performance on how fast you can make AI systems go to achieve a certain goal. And he led that effort particularly Intel's effort on showing how Intel hardware can be used to do world-class inference and speeding inference. He often comes to Chicago. He led the effort with Intel and Microsoft to place two centers of excellence in parallel computing, one at Berkeley and one down in Urbana several years ago. On this time last year, he was giving a lecture down at the University of Chicago on what Intel's doing for accelerating inference on Intel processors. So I'm very glad he could make it. One interesting factoid, and we were sharing a little story about this. Years ago, there was a computer company based in Cambridge called Kendall Square. Some of you might remember. They had a really innovative architecture, an all-cache architecture. And I was an advisor to that company, and he was a grad student writing code for that machine. So we actually shared some hacking experiences. So please welcome Wei Li to the stage.
Okay, thank you, Rick, for the introduction. I'm very glad to be here. As Rick said, I worked on high-performance computing for a long time, and now coming back to the AI side. And for those of you who know, actually, when I think about artificial intelligence nowadays, it is really a special version of HPC here. Okay. So I have a very simple job at Intel. Actually, we just want to make sure we do both software and hardware innovation to make sure AI works really well on Intel scale products here. So why software and hardware together? Many of you who have been looking at a lot of performance comparisons and people building different kinds of machines, and quite often what they will tell you here is how many flops you have, right? That's a very hardware-specific view of what performance is. And most recently, in our lab, we actually improved our software quite a bit. And only by adding optimizations to software, we were able to improve performance by more than 200x. Right? So if you can do that level of performance variation, and software really play a very important role in terms of getting the best performance you can out of the machine here. Right? So software and hardware co-design and co-optimizations are really key to getting the best performance here. Now, why does scale matter? Because Intel, as you know, it's a small company in the Bay Area over there, right? No, I'm serious. It is small in a sense. We have expanded our TAM very significantly. So we used to be just a PC company. We were a big shot in the PC company. But when we get into the data-centric era, we have all kinds of opportunities there. And quite often, we are not the largest company in the area, right? So we are small in that sense. But we do have very large scale. We have, I'm not clicking yet, okay. So we do have very large scale. If you have a data center, you have Intel inside. You have a cloud, you have you have an Intel inside. If you have a home, you have a PC, you have Intel inside also. So we are really everywhere. And just imagine if we can make all these things smarter, right? What would that do for you? So I was having that conversation at lunch today with Christine from Berkeley. I don't know if she's here or not. She's sitting in the back, and her immediate response was Skynet. Okay, but I'm sure our friends at DOE will take care of the Skynet part of it. So our job is to make all these machines smarter here. Now, you have seen a lot of applications already. Today, you have seen all of these different panels and looking at different applications. And they are, from healthcare, drug discovery, everywhere, right? So we are a infrastructure provider. So our job is to build the right infrastructure for AI, okay? So what I looked at this is, I actually don't look at the specific applications above us. I look at the performance characteristics of these applications, right? And my job is to build the infrastructure so you can run these things fast. When we look at these underlying technologies here, when you go below healthcare, go below drug discovery, at the end you come down to different kinds of AI techniques, and these things are moving very quickly, right? So people, when deep learning came out about 5 years ago, at that time it was all CNN, looking at cats and dogs, try to recognize these things, right? And over time, we have seen the adoption of RNN, recurrent neural networks, and for natural language processing. And the performance behaviors are different from the CNN alone, right? And now, if you look at other applications like recommendation systems used heavily by the cloud service providers, the underlying techniques are also a little bit different, right? And we run into things like reinforcement learning. So I was having a conversation with somebody from Lawrence Livermore Lab, Sandia Lab, sorry, I mistake. Sandia National Lab at lunch here, and he was telling me the different kind of simulations you can run when you look at the convergence of HPC and AI. So as a provider of infrastructure, we need to do all of these things well. And the good thing is Intel does have a scale here, right? So what do we do from both the hardware and the software side of things? So let me finally click my slide. So that will be my first slide. I don't have a lot of slides, luckily. So don't worry about, I'm between you and a drink here, so I don't want to hold you back for drinks here. Okay. So on the hardware side, we do have a very wide portfolio because on the AI side, as I mentioned, there are different kind of applications, right? And the foundation for our hardware strategy is we have a great CPU here. Okay? So you may not realize CPU is very good for AI and also for deep learning. As Rick mentioned, so the team I had that won the AI competition, we actually went in with a CPU, right? And that's because over the past few years, we have added a lot of AI features into the CPU. So for example, we have vectors that can operate on 512 bits. You can run things in parallel over there. And you can have a CPU node nowadays. Usually we have 2 sockets inside. Each socket is 28 cores, right? So you have 56 cores in just a single node. And one CPU node has more compute power than the parallel machine I used when I was a graduate student. It was just no comparison, right? So the amount of compute power is a lot. And even recently, we added more specific feature for deep learning, which is, as somebody mentioned earlier, deep learning does not necessarily require high precision, right? You can have a lower number of bits. So we added integer 8 into the CPU, and it's called VNNI. We've been applying this to many, many different models here. So we evolved a lot on the CPU side. Now, in addition to the CPU, we also do special purpose accelerators. And I'll just give you a few examples here. So FPGA, we bought a company called Altera quite a few 4 years ago. We had an Altera person here, Intel FPGA team here also. And we also have something called Movidius, where it is very low power. It's at like 1 watt kind of level. And that's something you can use to put in the camera or put in some kind of little small device, right? And in addition to that, we also have other hardware that was designed for deep learning specifically. So we, in the hot chips recently in California, we actually announced 2 chips over there. One is called Nirvana T for training. This is a specific design for training, and the other is Nirvana I, which is a specific design for inference. Okay, both of these have very specifically for deep learning over there. We also have GPU, which we're not talking about today here. Now, on the software side, that's the other side of the story, right? All the observations I've been talking about, these are all implemented inside software here. Now, luckily, I'll just give you an example here. For deep learning itself, the data scientists who would develop deep learning models, they only need to stay at the very high level of abstraction. And that they work with things like TensorFlow, Caffe, and PyTorch, and all that, right? And with all of these, we want to make sure they are optimized well on Intel platforms. And sometimes these are not sufficient. When they're not sufficient, we actually invented our own software for deep learning. For example, one of those is called Big DL for Spark. And for those of you who have a lot of data, quite often they are big data, they're already inside Spark. Spark at that time did not have any special library for deep learning, so we actually created a library for deep learning over there for Spark. Now, sometimes for inference, you want to have a special piece of software also. So we came up with a special software called OpenVINO Inference Engine. And that was designed for inference, optimized for inference specifically with a very low latency. Quite often for inference, you want the very, very low latency. And that inference engine is also optimized across multiple hardware IPs that I mentioned earlier, right? So with the same interface, when you try to use Intel hardware IP, you can only need to write once, and you can actually port easily from one hardware IP to another hardware IP, right? And we're doing all of these things through our math libraries, okay? And as I mentioned, Intel has been in the high performance computing domain for more than 20 years. And over the 20 years, we have developed a lot of capabilities in software, particularly math libraries. And for HPC, we have something called MKL, Math Kernel Library. So we extend that for deep learning. And we have something called, originally it was called MKL-DNN, for those of you who used that before. Now we just went through a renaming, so we rebrand this as DNNL here, okay? So with this combination, we have improved performance quite a lot on for example, on the single system here. So what does that mean here? So that means things that used to take a long time to run now is much faster. So when I came from Bay Area yesterday. On the way here, I was reading some blog which is published recently. So Intel worked with a company that is doing environmental conservation. So they're tracking penguins. They're counting penguins in the Antarctica, right? And because they put cameras over there tracking penguins moving, and it's getting a lot of data. Right? You can imagine how to train it with a lot of data. It's taking a long time. So it used to take days, so now it only takes hours on the system we have because we have a combination of hardware and the software optimizations, and things just move much faster now. Now on the other side, we also look at scale out. Right, we not only look at single node kind of optimization performance. Quite often your models are very big, and you want to run it on using multiple machines. So we have come up with a new library called Intel MLSL. It's a layer built on top of MPI. For those of you who in the HPC, you know MPI very well. So we built on top of MPI and specifically designed for deep learning. So it does all kinds of interesting communication patterns and so on. So it allows to do communication more efficiently. So with that, we are able to scale out. So my team actually ran measured performance on Amazon, right? So we just take Amazon nodes and we scale out to 128 nodes. And with very linear, almost very linear speed up over there for something like ResNet 50. And others did much more than that. They took our software, they add more things to it. For example, UC Berkeley, they did this on 1,600 nodes from a supercomputing center in Texas. We have a lot of people from Texas here. So there's UT Austin has a big supercomputer there. So it is making a huge difference when you have a combination of hardware and software here. Now the other thing Rick mentioned already, which is Aurora. So now I'm on the hook to deliver Aurora performance here, and I'm actually very excited about the machine here. So we have a new architecture called XE here, and we're building on top of the latest, greatest process technologies, and software will play a very, very key role here. So Rick and I were just talking, what kind of things we should do more, should do better, and we'll get there. And it is a huge opportunity for us, and I'm sure we'll make something great here out of the Aurora machine here. Okay. So to summarize, we are doing both software and hardware, and the combination of these two is going to be the key for our success on the AI side. Okay? And so if you run into other people who are trying to sell you machines, ask them more than just a raw flops, right? Ask them the overall real performance here, coming from both software and hardware. Okay, and we have a large scale. We have a small yet a big company. We do have scale, and we can have a huge impact around the world here. As somebody mentioned. Secretary Perry mentioned earlier today, we have a chance to change the world here, and we can scale out. And we are very excited to work with all of you here, work with government, national labs, and academia. I came from academic background. I certainly enjoy working with all of you here. So with that, folks, thank you for your attention, and on behalf of Intel Corporation, I would like to invite you to the networking reception next door. I know you where that is. It's a Gold Coast room, which is a place you actually got food today anyway, so you won't miss it. Okay, thank you.